Sorry about that, y'all. All right, everybody, welcome to Learn to Defend Cyber. My name is Joseph, and we're working on TryHackMe's Advent of Cyber on day number 12 today. I went ahead and got the machine started and saw today's topic is web timing and race conditions. So we are kind of going in the weeds a little bit. It's going to be, I'm going to keep it strictly high-level view, as this can get very, very, very technical, but for the sake of this walkthrough and for the sake of this challenge, we can keep it pretty high level. We just kind of understand the concept of what's happening, and then it looks like, if I saw correctly, we're going to be using burp to exploit a race condition in a web app. So let's define a couple things first. Let's pretend we don't know anything really quick. We can go ahead and start by defining, obviously, a web app. That's an application that's served over a web browser. Race conditions, and in programming, race conditions are when there may be two functions or two or more functions executing simultaneously, or maybe a function executes and then it has to do something else before it can finalize some other action, and what you can do is take advantage of that and maybe tamper with how it does what it's trying to do. Again, I'm trying to keep this very high level. We're going to talk about it more in relevance to this, so I'll be able to kind of explain what I'm saying better. But for now, you can just understand a race condition. It sounds like it does what it sounds like, right? Or it does what it sounds like. You have something racing with another thing, and then you get your objective completed, whatever that may be. Let me go ahead. I'm going to throw this into full screen so we can see it a little better as we try to do things. I can go ahead and close this out so we can read this better. And we'll talk about the story a little bit of what's going on. Okay. So we have Wareville's Bank had a huge turnover this year and expected massive profits before the holiday season. They were eager to disclose the news to the townspeople during the Sockmas celebrations. However, to their surprise, things went the other way around. After completing the annual calculations, accountants were shocked to see considerable loss. The bank called McSkitty to help investigate with the user's fraudulent transactions. Upon analyzing the bank's website transactional logs, McSkitty found some interesting transactions. A few users, including the mayor's team, initiated multiple transactions from the reserve account at once. Okay. All of these transactions succeeded despite exceeding the user's current balance. Glitch already knew of this vulnerability, allowing the fraudulent transactions and that mayor malware and his alliances, I assume that's probably supposed to say allies, exploited. And we can go ahead and talk about, it looks like we're going to, they give us some information. As always, TryHackMe does a pretty good job of giving you information on the things discussed in the room today. So let's go ahead and go through this for a second. Conventional web apps, easy to understand, identify an exploit. If there's an issue in the code of the web app, we can force the web app to perform unintended actions by sending inputs. Typically, we send some form of bad input to try and get it to do something else than it's supposed to do. So, neither understand, because there's usually a direct relationship between input and output. You put something in, you get something out. We get bad output when we send bad data, indicating a vulnerability. But what if we can find vulnerabilities using good data? So data that's actually intended to be using. What if the data isn't about how we send it? And then they go on to talk about, this is where web timing and race conditions attacks come into play. And let's dive into this crazy world. So when you're trying to exploit a race condition, you are pretty blind as to what's going on in the background, right? You don't see everything. You can't follow the execution unless, of course, you are able to follow the execution by putting it into a decompiler of some sort, or any kind of other reverse engineering application. Either way, most of the time you can't follow the execution, so you can follow, there's different breadcrumbs you can follow, like in the HTTP requests. You can try and see what kind of data it's putting through. You can also try and look for the length of time during execution. So, by making tiny changes in what we send, or how we send it, and observing response time. So yeah, say I send something that's good, and it's like, okay, this takes 5 milliseconds. Pretty standard, right? Say something, say I tweak it a little bit, and now it's taking 7 milliseconds. I have an idea, I'm like, oh, there might be something here. 7, this is, for example, 7 milliseconds, that's standard discrepancy. You should expect it to be within milliseconds of each other, but if you make it go thousands of milliseconds faster, or longer than it's supposed to, now you've got more of an idea of what's going on. Race conditions are a subset of web timing attacks that are even more special. With race condition attacks, we are no longer simply looking to gain access to information, but we can cause the web app to perform unintended actions on our behalf. They're very subtle because they are more exploiting how the code works without actually changing anything than anything, so it's harder to detect, and it blends in with traffic, so you may not even notice. Based on the following research, links to some research, response time differences ranging from 1300 milliseconds to 5 nanoseconds have been used to stage attacks. 5 nanoseconds, that's incredibly fast. I can't even fathom how quick 5 nanoseconds is. They can be hard to detect and often require a wide range of testing techniques, but with the increased adoption of HTTP2, they become a bit easier to find and exploit. So, Hypertext Transport Protocol 2 was a major update from its original. While most apps use 1.1 still, there has been a steady increase into the adoption of 2, as it is faster, better for web performance, and has several features that 1 did not, but if it's implemented incorrectly, some of these new features can be exploited. Key difference in web timing attacks between 1 and 2 is that 2 supports a feature called single packet multi-requests. Network latency, the amount of time it takes for the request to reach the web server, made it difficult to identify web timing issues. It was hard to know whether the time difference was due to web timing vulnerability or simply latency. Latency, by the way, is just the amount of time between request and action. For a simple example, let's say that I throw a ball at the ground, it takes 2 seconds to hit the ground. There was 2 seconds of latency between me throwing it and the ball hitting the ground, right? So, with single packet multi-requests, we can stack multiple requests on the same TCP packet, eliminating network latency from the equation. So now, you can attribute time differences to different processing times for the requests. It's less about how long the packet took to travel, and more about what was actually happening on the back end. So, typical timing attacks. You got information disclosures. Leveraging the differences in response delays, a threat actor can uncover information they should not have access to. For example, timing differences can be used to enumerate the usernames of an application, making it easier to stage a password guessing attack and gain access to accounts. And then you have race conditions, which are what we're talking about today, where you can have the application process requests in a manner that it shouldn't typically process them if we send the same coupon request several times. So this is a great example. If you send the same coupon request several times simultaneously, it might be possible to apply it more than once, right? So because maybe if the code is written in a manner where it's not applying this coupon immediately, it might be where I can just spam it 10 times and a 10% discount has now turned into a 100% discount, and it's not going to really notice because of the time of the check. We'll look at a time of check, time of use flaw, as shown in the animation below. So you have a device sending information to the servers. We have a time graph here. It's we're submitting the code. This is a GIF, so we're going to have to wait for a second. So we submit the coupon code. and it checks to see if it was already used, so it applies the discount, and then it sets a flag to show that this coupon was already used. But what happens if we were to send 10 of those requests at the same time, and it doesn't have the time to check that next condition, is it would apply the coupon multiple times because it hasn't been able to set that coupon code to used quite yet. We did it faster than it could process. So, let's win the race. Now that we understand the basic concepts related to race conditions, we're going to go check out this Wareville banking application hosted on the machine that I started earlier. By the way, if you are following along at home, there's a button that says Start Machine that is going to launch this banking application, and your attack box is up top. So we'll go back down to where we were, and we will visit. You know what? They want us to use burp, so I'm going to have to close this Firefox and open burp. Welcome, y'all. What's going on, Kira? We got Hairkit Fish. We got Jose. Jose talking about being reminded of playing Halo because of latency. Absolutely. I remember way back playing games back when I was still on like super crappy internet and having a ping of like 500 milliseconds, and everybody had like a similar ping because internet was horrible, and you just see people like skipping around the map. Oh, it's beautiful. Jeff, welcome. We're waiting on burp to get spun up. Always takes a moment. And once we go there, we're going to go ahead and go to the Interceptor tab and get our proxy started so we can browse to that bank. And I have to make sure to edit the setting. By the way, anytime you set up burp, if it's brand new or if you never saved the option, you have to actually turn off the setting to make burp use the sandbox so that you can use its built-in proxy. Its built-in browser, that is, sorry. We'll go ahead and save the project in memory because we're not coming back to this. We'll start it. We don't need to name it. This isn't for a real test, so I don't want to have to save anything, and when I'm done using the machine, it would be gone anyways, so... Did that come up on stream? I don't think so. It shouldn't. No, okay. Alrighty, so let's go over here to proxy. We got our interceptor. We'll go ahead and turn it off for now. It says that we have a new version we can install. We'll go to settings, go to burp browser, and then should be right here. No, sorry. Where do they keep that setting? I thought it was in burp browser. Yes, okay, you have to tick it on, not tick it off, sorry. Allow burp's browser to run without a sandbox. And then you just go ahead and hit open browser. And we will get the burp's built-in browser. It uses Chromium. This one always takes a moment too, so bear with me. Am I using a beefy computer? I mean, my computer's fairly good, but I'm actually doing all of the attacks through the Try Hack Me attack box, so it always takes a moment. The attack boxes, especially during Advent of Cyber, do struggle a little bit. They are just virtual machines, so things take time. Nothing on my end I can do about that, just a little bit of patience and all is well. It's not actually that slow. They're pretty fast for being virtual machines. So let's go to that address that we found earlier that we got from spinning up the machine and see what we're doing. So we got our proxy intruder repeater tabs. Those are, again, I mentioned this a few days ago, proxy intruder repeater. Those are like the 3 tabs that I tend to use the most. There are plenty of other tabs that are great, but for somebody as simple as me who isn't really a red teamer, but more uses burp and CTFs or challenges like this, those are the 3 tabs that I find myself in the most. We already did this. And once I browse the URL, blah, 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 we can see the login area, and we got it. We have creds, so we can go ahead and log in. 110, and then the password was tester. So we log in. We'll see our dashboard. We have $1,000. That's a lot of Chick-fil-A nuggets. And we see 2 functionalities, log out and then fund transfer. So it looks like it's just a pretty simple application used to send money between accounts. Okay, and we can verify it. It will generate a lot of get and post requests, which we can look at after we send the money, because we are in a browser and Burp is capturing everything we're doing. Let's go ahead and send $500 to account. Where do they want to send it to? 111. So we'll send $500 and transfer it. Nothing happens on our end, but we can see that we have a transaction ID generated and the balance of 500, so it did take our money. And in the background, we can go to our HTTP history and see what happened when we did that. We have a couple post actions right here. So this post action would be the transfer. Okay, we can see that our account number, or we can see the account number that we were transferring money to and how much we were transferring to. So this is kind of breaking down what we just explained. The post action, number 4, I'm sure they have these broken down somewhere. Oh man, they're gonna want us to do a lot real quick. But you can see that number 4 is that transaction. And it wants us to... Give me one moment, sorry. Alright, sorry about that. I was about to sneeze, and I did not want to blow people's ears out. Alright. So we have repeater, which allows us to send multiple HTTP requests. We will use this feature to duplicate our posts and send it multiple times to exploit the race condition vulnerability. So we can go to our post right here and send it to a repeater by right-clicking. You see repeater glows because we did something over there. We have our HTTP request. And we can change the account number from 111 and the value from 500 to any other value in the request as well, as shown below. Okay. And it's telling us that if we are in here and we hit Control R, then it duplicates the request. So you can see that we have 2 tabs now, 1 and 2. We have 2 requests, 2 tabs. Press Control R to have Control R 10 times to duplicate it 10 times. So let's go ahead and click it 8 more times. Alright. Now that we have 10 requests ready, we want to send them simultaneously. While one option is to manually click the send button in each tab individually, we aim to send them all in parallel. To do this, click the plus icon next to request 10 and create a tab group. So go ahead and create that tab group. You can just call it group 1 and add all of our tabs that we created previously. So now we have them all here as group 1. You can just click it and then you see we have 10 items in there. And now we can do actions as a group instead of individually. It names it funds. I kept it boring and just called it group 1. We can hit send groups in parallel, last byte sync in the drop down, and then click the send button. Once selected, the send button will change to send groups parallel. Click this to send all duplicated requests in our tab group at the same time. So We can hit this drop down. Send groups in parallel. You just click it. So it should. So we got a 302 error. Go over here and see what happened. Well, it definitely worked. We are now $4,500 in the hole. So what happened? What happened is we we sent the request 10 times. Normally we would have hit 0 if we would have tried to do this 10 times individually, right? We would have just been like send 500, send 500, send 500, click, transfer. When we hit 0, it would have stopped us. But because everything happened at the same time, it wasn't able to process that we were already below 0, and it just sent all of the money. It said, okay, we got it, and then each request would have hit the function to decrease our bank value after everything was sent, and it just allows us to go right on through, and we are now $4,500 into the hole. Once all the requests have been sent, navigate to the tester account in the browser and check the current balance. Yep, we are definitely 4,500 under. By duplicating 10 requests and sending them in parallel, we instruct the system to make 10 requests, each deducting 500 from the tester account and sending it to 111. In a correctly implemented system, the application would have processed the first request, locked the database, processed the remaining requests individually. However, due to the race condition, the application handles these requests abruptly, resulting in a negative balance. And somebody in 111 just got a lot of money that doesn't actually technically exist. So, it looks like they give us the source code here. We can see, we can go through this. Looks like it's pretty simple code. If the balance is greater than amount, execute update user set balance, where balance is plus where account number equals. So this looks like this is receiving the target. Yeah, so this is the target account. This is, it receives the money first. So the target account that we send money to receives the money first. And then after it receives the money, it sets our balance as the person who sent the money to negative. Or to minus whatever we sent. In the above count, we have user balance equals application first updates the recipient's balance. Yep. And followed by a commit. That's that right there. That's the commit. So it updates the recipient, commits, then it updates the sender. And commits again. Since these updates are committed separately, they are not of a single atomic transaction. There's no locking or synchronization. As we saw, we just sent as much money as we wanted. Now, can I try, for sake of proving that this might not work, let's just try sending another $500, even though we're already negative 4,000 under the hole. Does it let us? Yeah. So it tells us that we don't have the money. So now, we can go in and log in as Glitch. We can log out of our now broke account. We can't afford even a single chicken nugget. Christina's here. What's going on, Christina? Welcome. So we'll log in to Glitch, who is account 111. That is the account that we sent all of our money to. And oh no, he's 101. I can't read, sorry. He's account 101, and his password's pretty simple as just Glitch. So he has $2,000, and we are about to make that not a thing anymore. So they kind of just cut us loose here and want us to send over $2,000 from the Glitch's account. So what we'll do is we'll just capture that, and remember we still have burp running in the background. We'll target 111 and we'll send $1,000 And it'll take a moment, it'll capture the request, we get a transaction ID to show that it actually happened. And if we go back to proxy, into the HTTP history, we can see that we have a new transfer right here. And this is from the glitches account. We targeted the account 111, and we sent $1,000. We'll go ahead and kind of rinse and repeat the same process we did earlier, right? We'll send it to repeater. See, it lights up showing that it got it. We got request 11. We can actually just go ahead and close all the tabs in this group because we're not using that group anymore. And we're going to follow the same process where we hit Control and R to duplicate this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And we can hit the plus button to make a new group and select all of our tabs here. And what we're going to do is we're going to do the same thing that we did before. We're just going to hit this drop down, send group in parallel. Boom. If we go back and refresh, yep, we definitely have negative $9,000, so it definitely worked. And we got our flag. THM won the race 007. We can go ahead and submit that. Did I... Oh, I included flag. I was not supposed to do that. Alright, now we can submit that. And if you enjoyed the task, as always, at the end of these days, they try to give you a room that points you towards more race conditions. And this looks like it's probably for the side quest, so we're not going to touch that. Now, today's video was done by Tiberius. I highly recommend watching it. Tiberius, he is a great content creator. I have watched him a good couple times. Haircut Fish is saying that when he sent over 2,500, it did not give him the flag. I'm not sure. So we'll go ahead and pivot over to this view. And we can, I've got a couple minutes. Now, I know BSEC is going to be doing this later. Jose Alfredo is agreeing, saying that he likes his content. Yeah, he does good content. I think he's known for doing like marble races before certain content. I'm not sure. I have seen I've seen the marble races, and they're always funny to watch, getting hype over marbles, even though there's like no, I don't know. It's dumb fun, right? But from what I was told by I know BSEC's doing it later, but I had somebody reach out to me earlier that was like, hey, it's race conditions. And apparently Tiberius' video, he actually pulls up Wireshark. I'm gonna watch it later. But in Tiberius' video, he pulls up Wireshark and actually shows the difference between sending it individually and then sending it one at a time by using Wireshark. So that is definitely great value. I would watch Tiberius' video. As I said, I was going to keep it a little high level today, just because it can get really down into the weeds. And for sake of the CTF, we did not need to go that far. We can speculate a little bit about this side quest, so long as I don't actually do anything with it. It sounds like where balances shift and numbers soar, look for an entry and an open door. So it sounds like somewhere in this web app where you are... it sounds like you have to be authenticated to an account, and there might be a little something hidden somewhere. I don't know if anybody's doing the side. We'll watch his too, thanks. Absolutely. No, yeah, absolutely. They picked really good content creators this year, who all did a phenomenal job. So today was a little bit shorter, which is nice, because yesterday felt long, and I don't know about tomorrow. But tomorrow is Friday, day 13, we're coming up. We're almost, we're about at the halfway point, going towards the tail end of everything. Just going over this to see if there's any kind of anything hidden in here. They didn't have any post story, and we were already aware of this vulnerability, so it was much easier to exploit. When you aren't aware of a race condition, it can kind of get hard to figure out that it's there or not. There are some of the more technical attacks, and as they said up here, it's pretty hard to find them sometimes. Alright. And with that, I'm going to go ahead and close it out for today. Thank you so much for watching. I appreciate y'all showing up. And I will see y'all tomorrow for day 13. Have a wonderful night.